So we are looking at this note that is very crucial, that yes, we know absolute extreme value exists, but how can we find them? And we need to have an approach. And here are the steps. So what is the first step? The first step is always find the critical values. Find all the critical values for the function over that interval. Then evaluate the function at each one of those critical value. And also for the endpoints, because endpoints are not critical value, but they could be max and mean. They could be extreme value. So they are also nomination, they can be nominated. So the first step is find the critical value. Second step is what is the output value? What is the value of function at those critical value? And also endpoints. And lastly, among those function values, among those output values, pick the smallest. The smallest is going to be the absolute minimum, and pick the largest. That's going to be the absolute maximum. Okay. So that's the strategy whenever you want to find the absolute max and absolute mean of a function. And I'm going to go over all of these steps by a couple of examples. So let's first look at this activity. So it says find the exact absolute minimum and maximum of each one of these functions. So let's look at the first one, x times e to the negative x over the interval of 0 and 3. So this is the activity. And in the example, in this activity, the function is x e to the negative x, and they called it h, I guess. They named it h. Okay, function h is defined as x times e to the negative x. And the question is find the absolute maximum and absolute minimum of this function over this closed interval. So by extreme value theorem, we know that because the function is continuous and the interval is closed interval, so there exists absolute maximum and minimum. We know that there are such values, but what are those values? So first step. The first step is find all critical values. So let's do the first step. Okay, to do the first step, what was the critical value? It's any point that either make the derivative 0 or the derivative at that point doesn't exist. So I need to find the derivative of this function. Okay, so to calculate the derivative, because this function is defined as the product of x times e to the x, I need to apply the product rule. The product rule says that it's going to be the derivative of the first times second function plus the first function times the derivative of the second function, which is going to be negative 1 e to the negative x. I can rewrite it. So this is going to be e to the negative x. We can factor e to the negative x. From the first one, we end up with 1. From the second term, we have negative x. And if you want to find the critical value, we just set this equals 0, right? So we solve the derivative equals 0. We solve this for x, right? So we say, what are the solutions of this? So observe that exponential functions are not 0. Remember, exponential functions are always above x-axis. They never reach 0. So there is no way that e to the negative x becomes 0. The only possible way for this product to be 0 is if 1 minus x is 0, which gives us x equal 1. So there is only one critical point. So the conclusion is that there is only one critical value, which is x equal 1. That's it. Okay, we found the critical value of this function. Now, what is the second step? The second step is that find the output value, evaluate the function at the critical point, each critical point, and also at the end point. So here, I need to find the, step 2, find f of critical values, so we need to figure what are the f of these critical values and f of endpoints, of the interval. Okay, let's do it. So about critical value, there is only one critical value, which is x equal 1. So we need to calculate f of 1. What is f of 1? Let's see. That means in your function, which is right here, h of x is x times e to the negative x, substitute 1. So it's going to be 1 times e to the negative 1. So it's going to be e to the negative 1. Okay. Or 1 over e, whatever format that you like. We also need to evaluate f of endpoints. What are the endpoints of this interval? So the interval is 0 and 3. You see, it's over the interval of 0 and 3. So I need to evaluate f of 0 and f of 3. So it's going to be 0 times e to the negative 0. 0 times anything is always 0. This is going to be 3 times e to the negative 3. So this is going to be 3 over e to the 3. Okay, we are done with the second steps. We evaluated now we have the output values. The possible output values for the extreme value are 1 over e, 0, and 3 over e to the 3. Now, the last step is now choose, between these output values, the smallest is the absolute minimum, the largest is absolute maximum. Okay, so the last step, step 3. Okay, identify absolute minimum and absolute maximum. This is the last step. Okay, so I have 3 values here. Definitely 0 is the smallest because 1 over e, 3 over e to the 3, these are positive values. 0, so is the smallest number. So 0, so this is the answer. Absolute minimum is 0. Absolute minimum is equal to 0 because among this, and this, 0 is the smallest one. Now, which one is greater? Is it 1 over e or 3 e to the 3? I'm not sure at the moment. Let me check it with a calculator. Let me go to a scientific calculator, for example. One of them is 1 over e, okay, or okay, 1 over e, okay, and the other one is 3 e to the 3. Okay, so between these two values, the largest one is 3 over e to the 3. So that's the greatest one. So that's going to be the absolute maximum. So absolute maximum is 3 over e to the 3. So that's it. In this example, you saw all the steps. So every time you want to determine the absolute maximum, absolute minimum, you need to do these steps, right? Do these 3 steps. And here is a worked example that the function is given, is continuous over the closed interval 0 and 3. The question is find the absolute max and minimum. The first step is we find all the critical values. And we see that in this example, there's only one critical value. So second step is that we evaluate f at the critical value and also at those 2 endpoints. And the last step is now between these values, the one that is the smallest is the absolute minimum. The one that is the greatest is the absolute maximum. So that's it. This is the idea and approach, and you can apply it to all of these problems. So the rest is very just follow the same pattern, same approach, and try to determine the absolute minimum and absolute maximum of these functions. So in this picture, let me see what's this picture. So in this picture, it says that this is a function g considered on 3 different intervals. Oh, okay. So it says that the interval we choose has the same influence on the extreme values. Yes, of course. Depends on what interval we are looking at. We may have different absolute value and absolute minimum and maximum. If you're looking at the entire domain, so that's a different story. But when you're looking at closed interval, then maybe on the function has some absolute minimum at this interval, but it has another absolute minimum on another interval. So it definitely depends on definitely the interval that you are focused on has a major role on this answer. Okay, that's it. So that's the end of this section. So in summary, we are interested, we learned about relative extreme values, but we are also want to find the global extreme values. Then we introduce the extreme value theorem, and then we showed an example to how to use the approach in order to find the absolute extreme values. Let me find a good example. What is a good function? So the last one is the sine function. And the question asks you to find the exact absolute minimum and maximum on any of this interval. I might try one of them. So this is last question of the section. This is exercise 4. So this is exercise number 4. And the function is 3 sine of, so it's named S. It's 3 sine of 2 times t minus pi over 6, okay. And then plus 5. Okay, and let's try it over interval. Let's find absolute max and mean, like on pi over 6 and 7 pi over 6. Pi over 6 and 7 pi over 6, okay? So let's try this one. So the first step is to what? The first step is find a critical value, right? Find all critical values. So we need to take the derivative. So let's take the derivative of this function. The derivative is gonna be, so this is a 3 carries. We need to carry out the 3 because it's just multiplied. What is the derivative of sine? It's cosine. However, the input also is multiplied by 2. So I need to apply chain rule. Chain rule says that first take the derivative of inside. Okay, derivative of inside is gonna be 2. Like imagine you have 2 times x, 2x. What is the derivative of 2x? Is 2. Here you have 2t minus pi over 6. So that's the derivative of the inside, the inner function. Now, what is the outside function? Is sine. Derivative of sine is cosine. Cosine of whatever is the input value. And the derivative of 5 is 0. So that's it. So the derivative is 6 times cosine of the same angle, the same input. Okay? We need to set it equal 0. Set this equal 0. So then we have 6 cosine of this guy equals 0. So this is 0 if and only if cosine is 0. Cosine of, the cosine at those angles must be 0, right? And we know that cosine is 0 at like pi over 2, 3 pi over 2, and so on, right? Angles like this. Any multiplier of pi over 2 and 3 pi over 2, cosine is 0 at those angles. So that means this angle must be a multiplier of multiplier of pi over 2. However, since we are looking at pi over 6 and 7 pi over 6, so we don't need to really look at, you can look at the entire domain and then restrict it, but in fact it is already restricted. It's restricted between pi over 6, this is pi over 6, right, and 7 pi over 6. So if it is 8, if it is 6, 6 is gonna be pi, right? So it's right here. 7 pi over 6 is about around here, right? So it's really pi over 2. So let's just start by pi over 2, because really, let's start by this, and if there are more angles, we can figure it later. So that means, so cosine is 0 at this angle, so that angle could be pi over 2, because we know cosine of pi over 2 is 0. So let's solve it for t. So then this is gonna be pi over 4, divide both sides by 2, and then add these to both sides. So this is one possible pi over 4 plus pi over 6. So that's one possible, for example, critical value. Is there any other critical value? Let's try. I don't think 3 pi over 2, but I can try it. Because if you set this equal, cosine of 3 pi over 2 is 0. I'm just not sure if t would end up in this region. Let's see. So it's gonna be 3 pi over 4 plus pi over 6. No, it's gonna be, I guess. Because this is 7 pi over 6, right? 3 pi over 4 is 1, 2, 3. No, it's beyond. This is beyond that. So no. Because this angle, right? It's 3 pi over 4, 1, 2. So it's gonna be 1, 2, 3. And then, wait, one more time. 3 pi over 4 plus pi over 6. No, it could be. Because look, this is pi over 4. Now 3 pi over 4. 1, 2, 3. So this is 3 pi over 4. And then plus pi over 6. So it's going to be somewhere here. Yes, it stays in our region. This is our interval, right? Between pi over 6 and 9. So that's also possible. So there are two critical values, this and this. At the beginning, I was not sure if this is gonna sit in the restricted domain, because our domain is pi over 6 to 7 pi over 6. So there are infinitely many values that make the cosine 0, but we are just looking at this interval. So these two are the critical values of this function. Okay, now the second step is evaluate f to find f of critical values and f of endpoints. So we need to do these calculations. We need to find f of critical value. So that means finding f of pi over 4 plus pi over 6. This is one critical value. You can simplify it, of course. We need to find f of 3 pi over 4 plus pi over 6. So these are critical values, and also f of endpoints. Endpoints, f of. Endpoints means endpoints of the interval. The interval is pi over 6 to 7 pi over 6. So it's going to be f of pi over 6 and f of 7 pi over 6. So we just need to find these four values. One more time, look at the formula of the function. It's 3 sine of, maybe I write this down. It's 3 sine of 2t. In this case, t is pi over 4 plus pi over 6. And then what's the rest in the formula? T minus pi over t minus pi over 6 and then plus 5. Okay. And then plus 5. Okay, so I just substitute this input value into the formula of the function. Now let's do it. So this by this goes, and then this is gonna be 2 times pi over 4 is gonna be pi over 2. Sine of pi over 2 is 1. 3 times 1 plus 5 is 8. Now let's do it for this value. So here the input is 3 pi over 4 plus pi over 6. So we substitute this value into the function, into the formula of the function. This by this goes. This by this is gonna give me 3 pi over 2. Sine of 3 pi over 2 is -1. So it's gonna be 3 and then -1. So it's gonna be 3 minus 5. So this is gonna be -2. Now here, 3 sine of 2. Here the input value is pi over 6 minus pi over 6 plus 5. Okay, so this is gonna be 0. Sine of 0 is 0, so it's gonna be 5. And the last one, the input value is 7 pi over 6 minus pi over 6 plus 5. So 7 minus 1 is gonna be 6. So this is gonna be 6 over 6, so it's gonna be pi. So it's gonna be 2 pi. Sine of 2 pi is 0. 3 times 0 is 0, so it's gonna be 5. Okay, we are done. We found these values. So this is the f of critical point, this is f of critical point, and these are f of endpoints. Now, in the next step, in the last step, we just identify the extreme values. Identify the extreme values, which means that pick the smallest one and pick the largest one. So between these four values, the smallest is -2, the largest is 8. So that's the final conclusion. What is the absolute minimum? Absolute minimum is -2. What is the absolute maximum? It's 8. So here we showed you again steps of finding absolute extreme values for a function over an interval. And in this case, you have a trig function, and we are looking at the closed interval of pi over 6 and 7 pi over 6. And then we said that, okay, over this interval, the absolute smallest value is -2, and the absolute largest value is 8. So as you can see, the process is the same, no matter of what is the function, what is the interval, the process, the approach is the same. do first to find the critical values, then evaluate the f at critical values and endpoints, finally identify the absolute extreme values. So that's it. You just need to have practice in order to master this concept. And there are a couple of functions in the activity, more examples in the exercises. So I encourage you guys to practice this so that you will be ready for the homework assignment of this section. Thank you for watching in this video. I will see you next time.